How are we doing, everybody? So this is the 2015 higher level question 4. It's the developments question and it's the junior cert. So we're being asked to draw an elevation or plan as shown, and then we're asked to project an end view in the direction of ROP. And then we're asked to do the development of the conical surface, which is A, and then the development of the cylindrical surface, which is B. So first things to note is this ROB, or ROP should I say. So it's looking in from the left hand side, so the end view is actually going to be on the right hand side of the elevation. So that gives us a little hint as to where to start our elevation. So we're going to start in the top left corner, which will give us plenty of room to do our end view then on the right hand side. So our overall height of our object, so it's at about 30, 40 is 70, and 20 is 90, and then 30 is 120. So we need at least 120 in height to work with up here. So I come down about 140 from the top, and I just draw a horizontal line, which is going to contain my elevation and my end view. So I'll go ahead and start my end view here on the left hand side. So the base length of the object itself. So if you just look at your plan, we're told we have a diameter of 80 and diameter 44 for the cylindrical part. So for the cone part, for the base, I'm just going to do 40 40 either side. So I'm going to find a center line and I'm just going to go 40 40 either side. So if I just say there's the center there at 4, and then just go 40 this way, back to 1, or back to 0 should I say, and then 40 the other way to 80. While we're here, actually want to have my center, and the cylindrical surface has a diameter of 44, so if we just go 22 either side of that center, so there we have it. So I'll just actually bring up the cylindrical. Actually, I'll bring up that center as well. Okay, what I'll do is I'm going to measure up then those distances that we're given, the heights. So we're given 30, 40, 20, and then another 30 gets us up to that 120. And I'm just going to bring this a bit further up for me. Bring them horizontally across. So these are the heights that are given to us in the question. Okay, so straight away that's going to allow me to find the start of the cone, or the left and right of the cone at the base of the elevation. So anything I do in red, guys, should be nice and light with a sharp pencil. We're told we to come in 10, the elevation for the sill part. Then that goes up to 20. Okay, so we basically have our elevation drawn, so I'm just going to go ahead and put it in heavy. And actually just this diagonal line. That goes from the center, it does. Okay, so that's our elevation drawings. Our plan, I'm going to put it, just bring it 20 mil below, should be loads. I'm going to bring this center line down because it's just, our plan is only 2 circles. So we're told out the large one is the diameter of 80, should I say? Sorry, diameter of 80. So I'll put 80 there into 4. So that's the center, and then that should extend all the way to there. And the smaller one has a diameter of 44, so radius 22 again. So that's a radius there for that smaller one. Right, let's go ahead and draw those circles. Where did I say our center was there? So radius 80, or sorry, 40, diameter 80. It's the larger one, and then one-sided. Make sure we're accurate. Okay, so I'll just try to focus that for you. A bit better. Okay, so you can just about make out the larger circle and the smaller circle. I'll actually bore that in a heavier if I can for you. Okay, now it's a bit clearer for you. Right, so that's our plan done. Now to go ahead and do our end view. So what I'm going to do is I'm going to, from the bottom of our elevation, I'm going to pop off at 45 degrees. So this is the furthest point of our elevation. So I'm going to pop off at 45 degrees from there. Nice and light. With a sharp pencil. And you can bring your plan over to meet that 45 degree line. Okay, and then to find our end view, we're just going to bring those lines that met the 45 degree line vertically up. So nice and light, sharp pencil. The last one. Okay. So we'll bring our heights over from our elevation then. So just bringing them horizontally over. So as always guys, you can fast forward ahead on. Don't wait for me. If you want to just get quickly to the development part, drive on, don't be waiting for me. Okay. So first things first, I'll do those two for the cone. The base, I know the angle will be the same. So what I'm doing is I'm taking, basically drawing that again. So I know that's the extreme left of the in view, and that's going to be where the cylindrical section starts, and I know that's the height, so we can just draw that diagonal line there, and the same on the other side. Okay, so we're going to have to bring a couple of more lines down to our plan. So those two lines I brought down, bring them into the plan part of the cylinder, and bring them over and up to your end view. So I'm basically trying to find this here. So if there's there. Yeah, okay, so there it is there. I'll put that in heavy just to show what actually I put. So I know that's in my end view. Just try to make things clearer for you. That's in the end view. That horizontal line will be there. So the base. And okay, so that's the extreme left of the cylinder and the extreme right. Now, this is going to be the inside. Okay, so it might be a bit tricky for you to be able to visualize that part. Yeah. Okay, so now what we can't do just yet is this curve. So when you're looking in that direction there, the back here is actually going to be a curve. So we're going to have to divide up our cylinder here using 60-30 and locate those points on this slanted edge, and then that will allow us then to draw that curve, that freehand curve. So we're going to 60-30 our plan. Do you know what? I'm just going to 60-30 the whole thing, because we're going to have to do it anyway for the development part. So okay. So what you want to do is you want to locate these points inside on the cylindrical cut up here on the slanted edge. So if I was to draw it here for you, so there's one, and there's two where the 60-30 meets it, there's 3, 4, 5, 6, 7, yeah, that'll do. So if we were to bring them straight up there, if you were looking in this way, it'd see 7 and 1 right there. Here's 6 and 2, and 5 and 3, and then 4 is already found. So there's 4, there's 5 and 3, 6 and 2. Okay, so I want to bring those horizontally across firstly. So 5 and 3 is on that line, 6 and 2, and then 7 and 1 is already brought across. So we're going to bring these 60-30 over from your plan up to your end view. So bring them over to that 45-degree line. So 1 is brought over, 3 we need to bring you over, 4 is up already because that's our center, 5 bring that across, and 6. Okay, and bring them up to your end view. So 2. So this is why we use a nice sharp pencil. So that's 2, 3, 4 is up there, 5, and 6, and 7 is up there already for us. Okay, so we need to match them up now. So 1 is already here, 2, inside there's 2, so there's 1, 3 should be there. Yep, there's 3, and then 4 is at the very top, and you can almost see it like an image. There's 5, there's 6, and then back to 7. Alright, so there's our freehand curve. You can go ahead and draw that. So that's 4. Okay, so that's our freehand curve. That's the top part done. Right, so that's the elevation plan and end view completed. Now to move on to our development. So we're on part C, so that's A and B done. So part C, we're asked to draw the development of the conical surface A. So this is A here, and then that's B up there. So we all know, but at this stage we're aware of what a development of a cone looks like. So we're going to have to try and find the radius for that arc. So the way we find that is in our elevation. You can use your end view as well, but I'm just going to use my elevation. So you can see the left side and the right hand side of the cone. I'm just going to extend them on and to pretend that it's a full cone. So we're going to develop it as a full cone, and then we're going to take away this part here which is intersecting with B. So we're going to pretend it's a full cone. So you'd see if I extend this on as well. So the left hand, right hand side, they meet there. Alright, so I'm going to pretend that we're developing a full cone. So they're only asking for A, but I'm going to, you can see it there, the cone. I'm going to pretend it's a full cone. Okay, so you can just about make it out. So I'm going to develop it as if it's a full cone. So what you can do is take the radius of the full cone. So the side length, so I'm taking that length. See that distance there? That's what I'm taking on my compass. Bringing it down here where there's plenty of space. And I'm just going to swing an arc. Okay, so I don't know the full size of it yet. So I'm just going to swing an arc. Right. And what I'll do is I'll just choose there as my starting point, and I'm going to join that back to the center. Okay, so there's the center, so I'll just mark the center as well, because sometimes you might lose that, and that's very important. So next thing, we need to try and identify where we're going to stop along this arc. So basically how big this development actually is. So it starts here, but where will it actually end is what we're trying to figure out. So from our 60-30 that we, in our plan that we divided into 12 equal parts, we're taking the large, now we're working with the outside circle here, not the inside circle, the outside, so the outside, the base of the cone, and you just want to take one division, alright, so there's that one there, alright, they're all the exact same. Okay, they're all the exact same. So just make sure your compass is nice and accurate when you're setting it up. So they are all the same. So no matter where you go, they should all meet up, and they do if you continue on the way around. And you'll notice there's 12 divisions there, so we need to mark this off 12 times on this arc. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then last but not least 12. Okay, and you can join from that last one to the center. Okay, so that's our development, but we're not quite done yet. That is the development of the whole cone. So that is the development of all that cone there in our elevation. What they're asking for is only the development of surface A. So from our, where we took our original height of our cone, so instead of taking that distance, take from the apex down as far as where it's going to be cut off by that cylindrical surface. So it's only that distance we're taking, coming back to our center. So that's why it's important to locate our center again, and just swing that arc. Alright, so swing an arc inside that development we just found of the actual cone. And what you found in here is surface A. Okay, so it's very important to take that distance back. So what I took was from the, I'll show you again, so from the apex of the cone, measure down to where the cylindrical surface cuts the cone off. So taking that distance on your compass, bringing it down from the center, you're swinging that distance back around. Okay, so you can see it there, swing it around, and that's the surface we want. And just put the sides in heavy so that they know you're aware of which surface is being developed. Now don't go over the curve with your pencil in heavy, just try to leave it as it is, because it'll only end up getting messy. So that there is our development of surface A. Now, next thing we're going to develop is part D, which is development of the cylindrical surface. So I'm going to try, which we are going to, we're going to project this development up here. Okay, so we're going to come horizontally across from our elevation or end view. We're going to use this area here. Let me just see. Yeah, okay, so what you can do is you can just start bringing all these. So what we're going to do basically is we're going to fold it out here. We're going to use this area here, we're going to fold it out. So I'm going to bring across the important heights firstly. Right, so that's the overall height. Don't bring over any of those 60-30s just yet, or any of those points in the curve just yet. We'll just bring over a couple of these basic points first. So if we can get the basic shape first, try to get as many marks as possible first. And we'll just say it's going to start, so it doesn't matter where you started, but I'll just start it there. Alright, so that's the extreme left hand side. Okay, and we're going to actually start the development from, so what you want to do is when you're developing is you want to have as much of the material being used in the center. So what I'm trying to say is the smallest amount of material, if we were to cut this cylinder surface, right, you want to cut it, so I'll show you there. So if we're developing this surface here, okay, so what you want to do is you want to cut it at the shortest part. Okay, so in manufacturing terms, if we were to manufacture this, you want that to be the seam there, so you want that to be the cut, because then if you were given that amount of material to use, you can start the smaller part there, joins there, and when you fold it around it'll join back to that. So then our development, we have to try to sketch it here, it comes in there, goes up, in there, up, then you have this curve at the top, right? So that's the development we're trying to achieve here. So if you can try and imagine that, try to do a sketch of that first, it'll help you along the way. So first thing I'm going to draw is the, so we actually have the extreme left and right, so if we're going to cut the seam right there in the center, you can say there's the extreme left. Okay, so that's the start of our development. Now, how do I find this extreme right over here? Well, what we're going to do is we're going to take, very similar to what we did with the cone, we already divided 60-30, this smaller cylindrical part here. So you want to take one of those distances, so I'll take from the top here to this 60-30, and you want to do, what you want to do is mark that off 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So that's the extreme right over there. Our last one on the right hand side. So that's number 12 over there. And just put that in there. And then the base is just going to be a horizontal line, so just put that in. Okay, so we're getting somewhere. So what you want to do then is you want to try and find whereabouts these, or this line here is on our cylindrical surface. So very important to watch this. So you can't just use that distance there, because that is not a true length. Okay, so that's actually a curve. So we're going to have to try and find this line here. So we call it the line S and R. Okay, so find points S and R. So if we find points S and R here, so there's an S here at the front, but there's also one at the back. So if we were to look at it here, so we have to label these. You're looking in there. So there's S, R, P, and Q. S, Q, R, P are your points. So to find point S, I've done that right now. Probably, oops, there's P. So that'll be, so if we're looking at it here, there's P. P comes down. P should be at the front. Yeah, so it'll actually be P, S, and then it would be QR. So there's Q. I don't know why I had those letters mixed up anyway. Right, so then there's Q. Yeah. Okay, so then PQ, P is on top, so there's PQ. So you'll see that point there represents P and Q, and then S and R are behind those. So you'd have at the top is S and then R. So that point there represents those. Alright, that was a little bit tricky, but what you want to do is, because we're saying this is the extreme left hand side, you want to take whatever distance S and R are away from that. So there's where the seam is starting. At that point there is what I'm saying. So that's the shortest point there. So from here in our development, you want to take whatever distance S and R are away from that. Right, so that distance on my compass, and just mark that in the way, the top and the bottom. You don't need to do it, yeah, okay. So then I can draw a vertical line there, and what I'll do is we need to take, it's the same distance then back in for P and Q. So that distance again on my compass, and mark it in the way from the right hand side here, and then a vertical line there. Okay. Yeah, so we're happy enough there. So what we found here is S and R, yeah. So there's S on top, R on the bottom, P on top, and then Q on the bottom. Okay, so that's how you find those points. And last but not least then is just the curve. So I just okay, so our curve. So we've already 60-30 and we've already located a couple of points. So what we're going to do is we're just going to bring those points across. So there's 3 and 5. It goes across 2 and 6. And then 1 and 7 are found already for us. So that center line is there, yeah, so 1, 2, 3, 4, 5, 6. So there's our center line. Alright, so that's containing point 4. S is, and then that comes in. Yeah, so that comes into the extreme left. So that starts at 1, 2, 3, 7, 8, 9, 10, 11, and 12. So 10 and 10. And then if we were to work that way, that would be 4. 11, sorry, 11, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so try and match up your numbers with your plan. Alright, so mine are a bit off because I started with one at the top here from when we were doing this freehand curve. So that ended up 10 being here, and then that's 11 there. So at our cut seam it should be 10 and 10, and then you should be able to work your way in towards your center 4 then, right? So our curve actually starts at 7 and 1. So we can bring them vertically up. 7 and 1. Do you know what? You can bring them all vertically up because they're all being used. Okay, so 7 and 1 is where the curve starts. So you can just come horizontally from your S and your P over to 7, or 1 should I say, and then P into 7. There you go. So our curve is actually here. So to locate our points then, we already have found, because we've numbered them down here, it's made our life a lot easier here. So we brought 2 across, there's 2, so there's 1, and there's 7, so there's 2. 3 is brought across and meets 3, there's 3. 4 is at the top. 5 is the next one down, so you can see the mirror image coming in again. Alright, so there's our curve found already, and we can just go ahead and draw that freehand. So try give it as curve-like an image as much as possible. Try not just have it as straight lines. And we're done. So that is the development of surface B. Okay, so that took us just under half an hour, which is good going. So just to go back and explain this freehand curve here. So if we look at where we found this freehand curve here, so what we did was we 60-30 down here, and we numbered our points 1, 2, 3, 4, 5, 6, and 7. When we mark this 12 times across, what we were doing is basically finding each one of those and marking them across. So I referred earlier to where our seam is going to be the start of our development. So we want it to be at 10 there, at the smallest part. So if that's 10, if you look either side of 10, we're getting 9, 8, 7, 6, and 11, 12, 1, and so on. So 10 and 10, because there's 2 10s, because where they join up, if you think of the material, if you were to cut it here, 10 would go that way and 10 would go that way if you were to fold it out the way. So when they're brought back in together, they both meet at 10. So that's why there's 2 10s over here, if anyone's confused by that. So if you can just imagine flattening, bringing 10 that way and that way, 11 is going to be on the inside of it, on the left hand side if you were to look in there, which is why 11 is here, 12, 1, 2, and so on. And what I did then was, because we brought our heights across from this curve already, we can just match them up with the baseline. So 2, for instance, is there. I have 2 already found inside here. There's the height of 2, bring it across, and where it meets the distance 2 when it's folded out is there. So there's your point 2. So for instance 5, there's 5, and when you've numbered this properly, that's your life made a lot easier. So there's 5, bring the height of 5 across, and where it meets 5, that's your point, and that's your freehand curve. Yeah, so that's the 2015 question 4 development question, and done in full. So thanks for watching.